lot of this stuff is new, but it's going to seem very, very familiar to you because it's all the same type of core analysis that you would do if we were drilling oil and gas wells. So, but it's not. It's environmental maintenance type stuff, right? How many of you are aware that they're cutting thousands of feet of core in Florida every year? Probably not too many of you. But we're getting work down there. So let's kind of go over the basics of all this, what I'm talking about. Again, this is all non-oil and gas core work that we're doing. Starts off with the mineral extraction, right? This is the Smackover Formation in the Ark-La-Tex region. They produce the water, they extract lithium and bromide out of it. They re-inject the water. It's just a big water flood. And we're going to talk about all these in detail as well. This is one of the really cool things. So the water management wells down in Florida, the state of Florida, the way they describe it to me is there's 25 million people in Florida. They're surrounded by water, and it's just not enough, right? So they're targeted with managing that water resource for all those people, as well as one of my last slides, the socioeconomic influences and issues that they have there as well. These ASR, aquifer storage and recharge wells, as I'll show you around Lake Okeechobee and the Everglades, it's the water management districts is the state department there down there in West Palm Beach that manages those watersheds and monitoring wells. Of course, CCUS is still ongoing, although it's kind of lost a little bit of momentum, I think. It's slowed down a little bit, but we're still doing, in particular in Louisiana, a lot of wells over in Louisiana. With that, it's injectability, confinability, compatibility only, right? These water management wells, as I'll show you, they've got to, what they want to do is maintain water levels in Okeechobee and the Everglades and water quality. So after a hurricane or something like that, they need to inject the water. They want to lower that water level. So they inject it into the aquifers. And in the fall, in the dry season, again, maintain the water level. So they're extracting. So these water management wells in Florida, it's injectability and extractability, right? They need P&P. They need that kind of stuff. This is all, whether it's oil and gas or this environmental maintenance, it's all about getting fluids either in the ground or out of the ground as cheaply, as easily, and as safely as possible. So if it's an oil well, yeah, you need P&P. You need some formation damage testing. Same sort of stuff we're doing on all of this stuff as well. We're doing a lot of landfill. So landfill companies, I don't know who the big landfill company is here, but like Republic Services down in Louisiana, they can't just, they call it the leachate, the garbage juice. They can't just let it run off. So they drill 4,000-foot wells next to the landfills to dispose. And that's all over North America. A lot in Louisiana, Texas. We're doing a lot of deep injection wells in Florida as well, where they're going below the aquifers there. Industrial disposal wells, the Tampa Electrical Co-op, the city of Melbourne, Florida. They're generating dirty water from their utility plants. Again, 30 years ago, they would just put that stuff in the Everglades or in the Lake Okeechobee. Now they can't do that. There's a real environmental push down there. So they're having to drill these deep injection wells. Upstream is downstream and downstream is upstream sometimes. So if I was doing an oil and gas talk, same slide, right? You still want to do a description. You still need petrophysical properties. You may need some geochemistry, petrology. They do a lot of X-ray diffraction, XRF, that sort of thing down there, right? And a lot of special core analysis. They need a lot of formation damage. They need rock properties. They need rock mechanics, right? They still have kind of same as CO2. They have confining zones and injection zones. The injection zones are these large aquifers, the Floridian aquifer, the Avon Park aquifer in Florida as well. And we'll go through all that stuff. So early on, so let's start with a lab scope, right? Again, another slide that if I was doing an oil and gas, we would start with, we get the core in, we do a description, we do dual energy CT. That's a good way. I don't know if you're familiar with that or not. We do this on just about every oil and gas core we do. And we've done some of it on these Florida and disposal wells, right? It's a medical CT scanner. We scan the core. It's kind of like a density log, except it's way more sophisticated. I mean, we've got Core Labs has transforms where we can generate perm, porosity, rock mechanics, and things like that. So this is kind of one slide from a whole different lunch and learn. Maybe we can do that in the fall or next spring or something like that. And then a description. They're going to describe the core. They're going to look at the different lithologies. They're going to pick their sample points, and then we're going to take off. So sampling, P&P, got to get it down easy, right? They don't drill dry holes, but they drill uneconomic wells where they just can't, I mentioned the water management wells, in hurricane, 20 inches of rain, they've got to inject 2,000 to 5,000 barrels a day in the ground, okay, to bring that water level down as quickly as they can. But if they can't do that because of permeability issues or something, then they don't just drill these wells and, say an hour farther and hope for the best, right? They do a lot of science. They're spending a lot of money on all these monitoring type wells. They need all that permeability data, the porosity for storage capacity and things like that. So bulk volume of the injection zone, vertical and horizontal permeability, which is in the environmental term is thermal conductivity, right? Grain density, air perms. Obviously horizontal perm, just like in oil and gas, productivity index is kind of the main, I guess, index for injection efficiency. A lot of scale properties, a lot of petrophysics. But we also are doing a whole bunch of formation damage, right? They still need to know things like if they're injecting too fast, will they move fines, right? Injection rates. And I'll show you a lot of the scow work that we're doing there as well. But again, it's the same lab scope, just for slightly different reasons. So in case you've never seen a core before, we take an 1.5 inch plug. We take a lot of subsamples from that, geochemistry, the scow work, rock mechanics, and things like that. And then we start. So why? In some of these, it's got to be in and out. One day you might be extracting the water, and then Hurricane Toddy comes along, they get 30 inches of rain in Florida, and now you got to load it back into the aquifer. So injectability and extractability. For the mineral extraction, as I mentioned to you, this is around the Smackover, that southwest part of Arkansas. It's just a huge water flood. So they produce the Smackover brine, they extract that lithium and that bromide, and then they re-inject it. So every 2 or 3 years, they're monitoring this stuff constantly. They have on-site analytics where they can get ballpark context. Every 2 or 3 years, they start seeing a pretty significant drop in lithium contents. So now they know they're getting the recycled water, right? Now they need to move a mile over. So about every 2 or 3 years, companies like, I don't know if you've ever heard of Albemarle Corporation. They're in Baton Rouge. They're drilling these wells. And about every 2 or 3 years, the last time was about 2 years ago, they cut 700 foot of Smackover core. They spent $1 million on this stuff. They did sidetracks. We did a whole bunch of core analysis. And it's all about getting that water out as easy as you can and then re-injecting it, monitoring that, right? They make about 25,000 barrels of oil a year, incidental, and it screws up their whole system, right? Oh no, we're making oil. So it just messes up. The facility is pretty impressive. If you've ever been around Magnolia, Arkansas, there's not a whole lot of anything. I mean, I didn't even have a cell signal when I was driving up there. And you come up and there's this huge facility right there outside of Magnolia where they're drilling these wells. And then again, every couple of years, when the lithium drops, when it's not efficient enough to produce it here, they'll move over, they'll shut down, they'll drill a couple of new wells and do all this core analysis over again. So the water management wells, again, aquifer storage and recovery, they're maintaining water levels and quality in the places like the Everglades and Okeechobee. It's mainly South Florida. And as I said, the 25 million people surrounded by water, it's not enough. I went to the Florida Groundwater Conference in Orlando. Here's another thing too. I'm lucky. I keep telling Leanne, oh, by the way, doggone it. First thing I wanted to do is acknowledge my coworker, Leanne Hunt. Leanne is with our Houston lab, Houston office. She covers the Oklahoma area, sales for Oklahoma. Sorry, I told you I would do that first thing and I forgot. This has not been a good trip for me with, So anyway, Leanne is here. If you don't know her, you should for sure. She's here in Oklahoma on a regular basis. So I saw a talk. One guy gave a talk. He's a diver. He showed a lot of cool pictures from the freshwater springs in Florida. And he showed a picture from 30 years ago of a bass. And it looks, you can't even tell. It looks like it's just floating in air because the water is so clear. And then he showed one from this year, this past summer, and the water is really murky. And he was saying that even in that 30 years, even in Florida, one of us might look at it and say, wow, that's just gorgeous because it's got a little bit of color. But he said that the nitrate levels and the sodium, all of the fertilizer runoff, right? Florida's big agricultural area. I remember driving from Tampa to West Palm, and I'm thinking I'm driving in Louisiana, right? A lot of cattle and palm trees and palmettos and very similar away from the big cities, very, very agricultural centered lifestyles and things like that. And he showed pictures and he said, all of these springs are changing. So they're making a real concerted effort to better maintain these watersheds. The disposal wells are becoming very popular as well. Again, this is kind of taking over the country all over North America, from California to Michigan to Florida, Louisiana. There's a lot of them as well. Again, perm porosity, a little bit of formation damage. They've got to get rid of this dirty water, this leachate. And then CCUS, can I inject it here below the drinking water? I'm doing the same talk at the Texas groundwater, right? They want to know about their drinking water. So all these disposal wells got to go well below the drinking water tables, right? In Florida, the recharge, they inject them into the aquifers. And when I get to that, I'll show you some things there, the key points. The pumps are pretty damn rigorous pumps. 350 horsepower pumps down there in Florida, 10 to 20,000 barrels a day injection and extraction. So again, the mineral extraction is primarily the ArcLaTex. I was at a conference a couple of weeks ago, and I met a guy that works for the Mississippi Geological Survey. And man, he was like, you know, we're trying to get this play extended over into Mississippi. So they're trying to show, no, that's right. Sorry. We have a lot of core work from that, but the lithium levels are just not as rich there in the brines that are producing in Mississippi. You know, it's economics, right? This guy's just thinking, how can I get Mississippi to be mentioned in my presentation, right? Mentioned as one of the top one of the top lithium producers in there. And a lot of companies are moving into this. Brine production, you're extracting the lithium, the bromine, that distilled brine is then re-injected. Whoop. I'm not sure what I did. Oh, there we go. Okay, and we're back. It's essentially a large water flood. Those mineral levels are monitored. And as I mentioned to you, that oil they make really, really messes it up. They have to shut down for days to clean out their equipment and things like that. The waste disposal, utility companies, municipalities, landfill companies, the city sewer and water systems. Last time I was in Florida, I visited the Miami Water and Sewer Department. We do a lot of water testing there, scale modeling. We have a really sophisticated scale modeling software system, so we do a lot of that sort of stuff as well. The water table fluid compatibilities are very important when you're injecting this dirty water and it meets some sort of natural brine, whether it's high salinity brine or fresh brine. A lot of bad things can happen. So you need to do a lot of fluid compatibility type stuff as well. Okay, so the Florida stuff. When I do this in Texas, the gal that runs it said, well, make sure it's a big picture overview. So I'm going to start with this slide here. So here we are, right? There's Okeechobee down there. Okay, here's the lake. So all of these clusters, they call them, these are with these monitoring wells and these ASR wells. And again, they're trying to environmentally maintain these watersheds, Lake Okeechobee, and then the Everglades down south, level management, quality of the water management, right? So P&P helps you with timing and response. Higher porosity, higher storage capacity, higher permeabilities, the quicker you can get the water in or out, right? Higher injection rates, higher extraction rates, and things like that, less damage. So we're actually getting samples right here. They've done these two. So this is like a 10-year program, right? This is not something that's going to be finished by this summer. It's a long-term program. They core every one of these wells. They also take one of these wells, which they'll be doing about June, and they'll core the entire interval, like 1,500 foot of core, to do a petrology work, like continuous XRF. So it's a big project. It's a lot of core analysis, and it's the same stuff that we would be doing for you guys in an oil and gas well. If you want to see some cool stuff, if you're on Facebook, go to the South Florida Water Management District website and friend them or follow them. So I go every week. This is what they do. Like, think of a material balance on the lake, right? Every week they publish this data down here. Here's Okeechobee. Kissimmee River flows into Lake Okeechobee. So they're monitoring that. They're monitoring the rainfall. They're monitoring the release of water to the Gulf of Mexico side and to the Atlantic side, right? To say Fort Myers and Tampa and Naples and that sort of thing. And ultimately, what they want to do is have very little change, right? And if there's a big, in the fall, when rain gets scarce and things start to dry out, then they'll start extracting. Okay. Same thing. These are the water conservation areas down in the Everglades as well. Same sort of deal here. And it's got a lot of these really sophisticated lock systems, and it's pretty sophisticated system that they've got down there. But again, all those wells that we're seeing, they're doing core analysis on all that stuff. And just a little side note, there was a company down in Florida that used to do a lot of the core analysis, and apparently they didn't do a good job. They were losing cores, and so that's how I got in about 5 years ago. Right after COVID, we got contacted, and it's turned into a really, really good business relationship for us. A little bit more info. Look at this drill bit. I mean, it looks like something out of an alien movie, right? This is my pal, Caroline Smith. She helped me put this presentation. She's a hydrogeologist down in West Palm Beach. But they drill these 4-foot holes. So if you were drilling a 4,000-foot well, how long would it take you to drill? 5 days, 7 days? It takes them 3 months to drill a 4,000-foot well. Every 100, remember, it's environmental. We're talking about drilling through drinking water, what the people in Florida are drinking, right? So every 100 feet or so, they have to stop, pull out of the hole, get a water sample, analyze it. It's a really, really slow. You got to have patience. This job around Okeechobee that we're doing now has been, they've been planning this for about a year. We've been waiting to get cores there. But the rigs look like pretty big workover rigs, but they use big drill bits. They're very slow. I'm not a geologist, but there's the geologic age of this stuff. The upper Floridan is the main drinking water source there. I'm gonna show you a slide in a second. So this is an important slide. So this is the Kissimmee River cross section here. This dashed line is a very important line that's constantly being updated. It's the point where they suspect 10,000 parts per million total dissolved solids, right? Anything below that is potable. They can make it, they can treat it, and you can drink it. Anything above that number or deeper is considered undrinkable, untreatable, right? So the disposal wells, you have to be below this. Typically, you're well into the thousands. Look at the depths here. You're typically there in the 3,000 to 4,000 foot depths when they're drilling these disposal wells. But the aquifer storage and recharge, much, much shallower, 500 to 1,500 foot depths. But they're constantly updating this. Every time they stop every 100 feet, they analyze it for such things, right? Making sure there's still good, clean water, that they're not polluting or contaminating or something like that. So, and it makes for great sales trips, I'll tell you. Getting over there to these conferences are a lot of fun. CO2 has slowed down a little bit for us, I would say, but it's still ongoing. CO2 is much more complicated. The CO2 sequestration, as I say here, oh no, it's a two-phase system. So relative permeability becomes one of the main testing values that you need. You need to do a whole bunch of rel perm testing. You're typically dealing with higher pressures. CO2 has its own issues, right? But it's a very viable business market. There are companies now that do just this. Give us your CO2 and we'll get rid of it. You know, Carbon America, CO2, you know, specific companies that do just that type of thing, right? So rel perm, I don't know, you're all geologists, so you know probably what I'm talking about, but it's the permeability of two phases that interact with each other relative to the other. So we'll take a plug, we'll saturate it with water, and then we'll inject CO2 into it, and we'll see how the two phases interact. You do a whole lot of that sort of testing for CO2. You're calibrating that model. You've got to prove that your CO2, when you inject it, stays in place for 50 years, right? That it doesn't show up at the state park down the road in a faucet or something like that. For 50 years, you've got to have models that prove to the state or the feds that your plume stays in shape. So you've got to have a lot of data in the confining zones as well as the injection zones. A lot of formation damage testing as well. Injection issues, both from a compatibility and from a flow rate type testing as well. I'm not going to go through this a lot, but essentially you start off with 100%, right, saturation, and then you slowly inject CO2 at measure different saturations, and you plug all this data into a model, and it gives you the data that you need. But it's a very laborious and very rigorous testing method. Formation damage. You can mess up a lot of things by putting the wrong fluid, by flowing too fast. So we do a whole bunch of perm versus throughput testing, checking for fines migration. We start with a fluid that's considered pretty good, non-damaging, and then try different completion fluids, different brine, different salinity brines, mixing these brines. For these disposal wells, we do a lot of the leachate testing, right? If they've got multiple landfills, they'll combine them, and they'll all kind of different combinations of these different leachates, as they're called, the garbage juice, and testing it. Are you flowing it are you injecting it too hard? Critical velocity. wood pressure will start impacting the permeability as well. And then if you shut all this back, will you regain some of that permeability? So we do all this kind of stuff, and mineralogy as well. We'll talk about those. So again, different brines, right? You're checking the formation damage, you're checking the permeability impairment as you inject certain volumes of the brines. You know, what you don't want to see is a pretty big change there. The regain is if you shut it back, what will the permeability go back to, right? If you start off here, then you'll have a permanent permeability loss of that much there. A lot of that sort of testing. Critical velocity, am I injecting it too hard? Again, this is stuff you'd see with oil and gas as well, right? At what point where will the flow rate start moving fines? And then at that point, bring it all back, what's your loss in permeability as well? At what pressure do you start to change the permeability? It's compaction, you do a lot of rock mechanics, the compression, Poisson's ratio, Young's modulus, and things like that. And then confinability, the routine and the rock properties. Again, you've got to keep the CO2 in place. On the Florida stuff, it's the same sort of deal, right? If you're injecting something down there, right, something that's bad, whether it's CO2 or dirty water or a leachate, you got to make sure it stays in place. So a lot of rock mechanics, high pressure mercury injection, that's like a pore throat radius distribution when the testing there. Again, this is all data to build your model. With the mineral extraction, you want to determine where those confining zones are to kind of guide your water flood. Okay. As I mentioned, essentially the injection plumes need to have a 50-year lifespan in place. Model predictions for plume injection. Is that a little, yeah. Hi, there we go. For the water flood fairways. This is huge too. They do a whole bunch of petrology. As I told you, they'll core 1,000 foot, 1,500 foot, take samples every 10 feet or so and do XRD, XRF, right? A lot of X-ray diffraction with clay speciation. Not all clays are created equal. Some will react with certain injection fluids, some brines and some won't, right? We do a lot of scale modeling, a lot of water analyses and things like that, fluid sensitivities, the critical velocity, the water analysis, the scale modeling, that's all part of the standard. You guys know what X-ray diffraction is. That's a huge part. We do some of that. They also have a lot of, in Florida, they have a lot of relationships with some of the universities down there. They do a lot of that work for them as well. Just a couple of cool pictures, some SEM pictures of some typical clays. Again, not all clays are created equal. Some are much more likely to chip off, have fines migration, impair permeability. Just some more cool pictures. The water testing. So with water, we do it was oil field water analyses. We do these actually in Lafayette, but now they're turning into more environmental. You know, with water, if you have an ionic imbalance, that's what causes scale precipitation, right? It's almost like they're starting, almost like paraffin and asphaltene agglomeration when the conditions are right. So we'll do analysis. We'll plug that data into our software and equilibrate that water at a particular pressure and temperature, maybe weave the pH a little bit to see, and it gives you probabilities on different scale types, saturation indices. And we do a lot of this, in particular with the disposal, the injection wells, because they've got to test all these different waters and leachates and brines and things like that. So plug it in, it gives you likelihoods. I don't know if you know, what I'm told is above 0.5, you're good. Below negative 0.5 is likelihood. There's a pretty strong likelihood of scale precipitation as well. So we have an expert up in our Calgary lab that writes up a little summary for everything, and she's really good. So again, wrapping it up, the lab scope, you do a description to determine where you want to take samples. You need something in the injection zone. You need something in confining zones, right? You want to calculate P and P to give you bulk volumes and the ease at which it will be for you to get this stuff down there or extract it out. Horizontal permeability is one of the main concerns, if not the main concern, for injection efficiency. A lot of rock mechanics, formation damage. All this is going into your big models, right? And you need to make sure you don't, screw things up with formation damage. It's a technical term that I made up. Screw things up. You guys might want to write that down. Last slide, guys. So a lot of it's very complicated. Today I'm injecting this water. and then big rains come, or in North Florida, it all flows down the Kissimmee River, and Okeechobee swells by 1.5 feet within 3 days. Now I've got to start injecting it down. So I've learned a lot. Every time I go down there, I learn something new. The water management districts are a lot of smart guys, right? Their facility is very impressive. They're constantly monitoring these water levels. That lock, the picture of the lock I showed you. But it's not just that. The socioeconomic, geological, biological reactions. What do I mean by that? So in Louisiana, there was a parish, a county, that just voted not to allow any CO2 wells in their parish. Okay, and now the company that wanted to drill the well is suing the parish because they're not sure they have, the people have eminent domain over the land. So there's a big deal there. There's a lot of social issues with CO2. Some love it. Some think it's a savior for the oil and gas industry, and other people are like, hey, you're not putting anything in mind. Well, when I give this in Florida, I have to include this slide. You guys are aware of the python issue in the Everglades, right? Well, the water management district not only has to manage the water, but they have to combine that. They have these snake hunters that go out, and if you're not familiar, there's an exotic, over the last 50 years, people would buy these pythons in South Florida. They'd get too big and they'd release them in the Everglades. Well, now the Everglades and Okeechobee watersheds are overrun with these exotic pythons. They're out competing all the native wildlife and everything. And so the state is trying to get rid of them by hiring snake hunters, and yeah, it's interesting. Anyway, thanks for having me. Great to be here. Any questions? Yes, sir. For what? Have we? I have not. Yeah, I haven't heard. In Georgia. Wow. There's a reason the people glow in Louisiana, right? The reason they all look like me in Louisiana. Yeah. I am not aware of that, of other stuff. Yeah. And they're drilling deeper wells in Florida now. You know, they're getting worse stuff, so they got to go deeper. So the deep injection, real low permeability stuff. We'll see, but it's ongoing, that's for sure. It's not ending this summer. When I retire, I've already said I've handed it over to Leanne. Yes, sir. I'm not. You know, I don't have that data. I know the district has it. I'm sure they do. I mean, some really smart guys, but I haven't seen it. Yeah. South Florida Water Management District. So the state of Florida has 7 of these districts. The South Florida is based in West Palm Beach. There's also the St. Johns River and others. The Geological Survey is in Tallahassee, I think, Florida State University. But if you go to their website and/or their Facebook page, it's like Stanford University with the data that it's really, and their facility there in West Palm is really, really, really cool stuff. Yeah. But I'm sure there's tons of, you can access that picture, that lock that I showed you, you can access all of those real time. There's a lot of cool data. And if you guys know any geology students, right, a lot of opportunities in Florida for hydrogeology. Every time I go down there, hey, send students our way, you know. It's a cool thing, cool place. Yep. And it's Florida, whether you like it or not, right? Somebody else. Yes, sir. Right.
And you have change of administration. Okay. Have you seen where it's that fizzled out?
Absolutely. We was talking about that earlier. CO2 is definitely fizzled out. And now, 10 years ago, if you were using CO2 for EOR, well, you didn't get any credits, right? The CO2 credits. Now they've equated both of those. So whether it's sequestration or whether it's EOR, which is a, pretty valid tool, you're getting equal amounts of credit for using CO2. But I don't exactly know why, but it's definitely cooled off a little bit. Even with Trump in office, it's cooled off. Wait. Class 2, you said? Oh. Okay. Yeah. That part, yeah, I would agree with that. That the EOR portion of it. Correct.
EPA's rules on class 6 sequestration came to CCQ. It was basically just to dispose of CO2, confine it.
Yeah.
There's no financial reward for it. And the late 1940s, pushing West Texas, the largest projects were injecting CO2. So the little building, so the CO2 used in recovery in West Texas. That'll go back to the Railroad Commission, and the other CO2, the new one, is disposal of CO2. But with the credits, which is not like it's not a
Right. Yeah. It's still pretty busy in Louisiana. So Louisiana claims it's the geological hotspot, right? It's got the perfect geology. So there's still a lot of permit applications there, still companies that are still moving forward with it. But I think in general, elsewhere, it's definitely slowed down some. Yeah. Yes, Amy? Help me out here, Leanne. Certainly critical velocity, right? That's no matter where you are, what you're doing, you can't blow it and go too fast. Okay. I would say with CO2, I guess you do all of the formation, like regain perm with different. Yeah. I personally don't have a lot of CO2 clients. She probably has a lot more than I do. Mine are more than other stuff. But I would think it's very expensive, way more expensive than drilling oil and gas wells, right? Because of the regulations and like the Florida stuff. Imagine 3 months, 1,000 foot a month is every 100 feet, literally, they have to stop and reevaluate everything from scratch. And God help them if they find something, right? I haven't heard of any of that yet, but and once they start coring, it's maybe a month and a half of coring. So they send us, and in Florida, all the drilling companies, they hold all the cards. Florida Drilling, All Webs Drilling, they have their own core barrels. They all have 10-foot core barrels. So they run them, they cut the cores, they bring them up. They have geologists that describe them. They cut them up, and then they'll ship us just basically 1-foot sections at a time, multiple, and they'll take 2 or 3. It's not a whole lot of core, but it's just a whole lot of cores. Not a lot of core, but it sure is a lot of core. It's not a continuous 120 foot. It might be 10 1-foot sections, or this lake, it's more like 30 that they'll be sending us. And it's about anywhere between $5 and $10 grand per core section of work. The P&P, vertical and horizontal permeabilities, and some scow stuff. Yeah. Yes. It is, except now it's a lot smarter. Somebody asked us that, like Core Labs, we had a meeting with a guy here earlier. Well, so what's new at Core Labs? Well, one of the things is we can take cuttings, make a thin section, use facial recognition software in that thin section, do a description on it, and compare it to thousands of measured thin sections that we have in our database. So AI, we have the AAPG AI conferences in Houston. And they wanted me to do this one. Well, it's no AI. This is old school. But we also have somebody, our digital information creator, that's showing what we're doing with AI. So we're doing a lot of the CT scanning is really cool stuff, but it's just machine learning techniques of digital record descriptions and things like that. But the tools, the measurements, I don't think they've changed. Yeah, not in a long time. Not in a long time. Yeah, yeah, yeah. Somebody else had their hand up. Yes, sir. Okay. Mm-hmm. Well, they are doing lithium, but bromide is their main. Yeah, is the main bromine, bromide. Some of them. And I guess if the lithium doesn't, bromide doesn't change, but the one that we cored 2 years ago, it had been about 3 years since we had done it before. So they probably have some of the wells. You're right. I'm not going to argue that point. They probably have been online, but about every 2 or 3 years we do work for them in a new well somewhere out there in that Magnolia area. But I wouldn't doubt that. I walked into their office and they've got a map the size of the wall here of that smackover where they think they show where the oil zones are. They avoid those like the plague, right? So I'm sure there are areas that some of those wells have been online for 50 years. I wouldn't doubt that at all. Yeah. But we just, every 2 or 3 year cycles of drilling a new well and getting some core data for sure. You had a question too?
Well, I just had a comment. It's very unique. It's no other place in the country that's doing the same thing. The geology is very unique.
Right, right.
Water. Does that come into play?
It is. But there, so at this conference I was at in Orlando, they have a lot of companies that are trying to desalinate the seawater that typically hadn't been part of the equation, but now they're trying to get it to where maybe we can use seawater. So it's an ongoing research issue in the state of Florida. As of right now, it's mainly the aquifers that they're working with, but there's a lot of research on yeah. Sorry, guys. Donald Trump. Who the hell is that? Yeah, yeah. I don't know where it is, but there was a guy that gave a presentation at that conference, the Florida Groundwater Conference, and they were talking about that, the research. And the Texas one is in Midland in June, I think. Yeah. I don't know is there an Oklahoma Groundwater Association? Anybody know? Don't know. There is? Okay. I know there's one in California also. Okay. By the way, I don't think there's anything, if anybody would like a copy of this, I'm happy to send them a PDF. I don't think there's anything proprietary in there. Anything else? Christine, no questions? First time you don't harass me when you're one of mine. Anyway, thanks again. It's great to be here. I'll be around for a while. I'm bringing Leanne back to the airport in a little while, but I'll be hanging around for a while if you guys need anything. All right. Thanks, Amy.
Thank you.
Oh, okay, thank you very much. I've got another one from I'm trying to think of what it was. It's been a while since I've been here. Thank you, that's great. And a box? Excellent.
Thank you.
What'd you think?
It's good.
It's interesting.
17.
Yeah.
Development for people. Basically, how do I eventually stick develop?
Yeah. Yeah.
And that's what I need to do.
Good. Man, I'm glad you came, man.
I didn't know you were people when I signed up for this. I'll go to the Tulsa meeting. I used to work. It started.
Long time ago, yeah.
All right, good talk.
Thank you, man. Good to see you as always. I would love to. Keep her in the loop. Yeah.